Okay, so you guys actually, not that this is necessarily a good or bad thing, but you guys have actually seen this already because remember when we did the imaginary chapter in the last chapter, I did some of these, and this is when I kind of decided to split it up and do an imaginary chapter and a radical chapter. So you've actually seen some of this before. Now, obviously, I'm not going to just assume you remember how to do it. And I'm thinking some of these are going to be easier than what we did before. But I don't think today is too bad. I guess I should say, in my opinion, I don't think the math is too bad. You will have to make sure you remember some things. But again, considering we did the same type of problem with imaginary numbers, I think you'll be okay. So, we can't have any radicals in the denominator. I put in the instructions that includes I. I almost deleted that because we aren't doing imaginary numbers this chapter, but it's a good reminder, so I left it in there. Remember, you cannot have a radical in the denominator, so to get rid of that radical, you have to remember, imaginary numbers, we have to multiply the numerator and the denominator by the same thing. If the numerator and the denominator are the same number, that means it's actually 1, and you can always multiply by 1. So what are we going to multiply the numerator and denominator by? The square root of 2. And we do that because the square root of 2 times the square root of 2 is either the square root of 4, which is 2, or you could look at it as the square root of 2 times the square root of 2 is the square root of 2. Easier. Square root of 2 squared cancels that, or say it's the square root of 4 and realizing that's 2. I usually do the second way just because I think it's maybe nice. But if you want to take that shortcut, that's up to you. I'm going to get the square root of 4, and the denominator root 2 is 3 root 2. And remember that 4, we can reduce that to just 2. So that's what our answer is going to look like for this one. Oh, also, sorry, I accidentally put one-sided. That's why there's 2 pages of those separated for pickup. I'd like to blame someone else. I didn't click the right button. So the next problem is the same thing. Multiply the numerator and denominator by 3. By the square root of 3, I should specify. So square root of 3 and square root of 3 is the square root of 9. Now again, honestly, if you guys skip that part and just put 3, I'm okay with that. Some people realize that since there's 2 of them and it's a square root, that's just going to cancel out to be 3. If you want to do that, you can. I would recommend not doing that yet. I would wait until you do a couple of these first, but that's up to you. Then the numerator is square root of 6 times square root of 3 is the square root of 18. So that ends up being the square root of 18 over 9, or over 3. But here's the catch with this one. And you will not have these on a test or a quiz, or at least I will say, I'm going to try not to put these on a test or a quiz. This is very much one of the ones that I was trying to decide how difficult to make it, how easy to make it. And ultimately I landed on, I want to introduce you to this stuff, but I don't want to kill you with this stuff. So I just wanted to make sure I pointed this out. This numerator can still be reduced. The square root of 18, you can make 9 times 2, and the square root of 9 is 3, so it ends up 3 root 2. Now again, the problem with that is it even gets more complicated because 3 root 2 over 3, now the 3's can reduce and it's just square root of 2. Now again, if that's confusing, as long as you can get to this step, do all the other ones. It's going to be much more like this one. Honestly, if I was going to do that, there's also a way you can reduce this fraction from the very beginning. I don't necessarily want to get into that right now, but I did feel like mathematically, morally, I needed to at least show you a problem like that. But you will not, you'll either not have a problem like that, or if you do, if you just leave it like this, that's fine, because I'm going to try not to give you problems like that. Number 3. Now, there's actually 2 different ways to look at this one. Just like we did before, where if we had something 2 over 3i, you can either multiply the top and the bottom by I, or multiply the top and the bottom by 3i. Story for this. either multiply the bottom by the square root of 5, multiply by 3 root 5. If you multiply by 3 root 5, there is some reducing you could do, but I'm not going to hold you. Again, I'm trying to make it just the bare basics of this. But the easiest way, the quickest way, is to multiply just by that radical. Square root of 5 and square root of 5. When you do that, you end up with 3 times the square root of 25. We have 2 times the square root of 3 times 5 is 15. Now, just like we learned the other day with multiplying, since they are both radicals, we can multiply those together. We can't multiply the 2 by the 5 at all, but the 3 and the 5 are both inside radicals, so you can multiply those. Now, before you figure the answer, make sure the square root is just 5. 2 root 15 over 15. And remember, you cannot cancel out the square root of 15 and 15. Those are two completely different things. You can cancel anything in there. You'd end up getting something like 6 root 15 over 45 or something like that. If you leave it like that, that's fine. But it is, I think, a little bit more difficult that way. Any questions so far? So far, those are just monomial denominators. All right, go ahead and do number 4 and 5 on your own. I'll put up the answers here in a second. All right, put my answers up. Ends up being the square root of 14 over 7. And again, I'm completely fine. I recommend doing it maybe for the notes. But once you get going with this, if you realize that root 7 is just going to reduce down to 7, that's up to you. In my opinion, it is a little bit of a gamble, and you're going to have to, I guess that's where I use the term academically mature. You're going to have to know yourself and how good you are at math and how comfortable you all are with this stuff. Some of you guys, that's very much something that'll be easy to do. Others of you guys, I would not recommend it. Okay. Moving on, so now we're going to move on to conjugates. We mentioned this in the last lesson, and again, we did this back when we did imaginary numbers. You do have to be in standard form. The whole number has to be first, your radical has to be second. Once you have that, though, it's the same thing we did with imaginary, where it's the exact same thing. The only difference is you switch your sign. So if it's positive, the conjugate is negative. If it's negative, the conjugate is positive. That's all there is to that. I will say I haven't decided on the last test. I had a couple questions that said, what's the conjugate of this? I don't know if I'll have any on this test like that. I might put some on because, honestly, it should be easy points. So maybe I'll put 1 or 2 on. I don't know. But most of the time that we use the conjugates are when we have binomials in our denominator. Now, again, I very much took this from the imaginary lesson, so if you look back at that, it's going to be similar. But you cannot cancel any of this. The 2 over 2 doesn't reduce. The 6 and the 3 doesn't reduce. Since they're binomials, they don't work like that. If it was 2 multiplied by the square root of 6, and 2 multiplied by the square root of 3, then yes, we could do some reducing in there. But it's not, so we're not going to worry about that. Okay, so again, we go with imaginary numbers. So I'm hoping this isn't like too earth-shattering. You multiply the same thing we just did, but multiply the top and the bottom by the exact same thing. This one, the top and the bottom, has to be the conjugate of the denominator. Now that's important, the conjugate of the denominator. Test for that matter, a lot of people are doing the conjugate of the numerator. Remember, it's got to be the denominator. Now, same thing for, I do the same thing where I do my numerator and my denominator separately when it's like this, because it can get pretty confusing pretty quickly. 3 times 2 is 6. 3 times root 5, remember, you can't take 3 times root 5, so it just stays 3 root 5. A lot of people put 15 for that, or square root of 15. Numerator, not terrible. we have 2 plus root 5 times 2 minus root 5. Just like we've always done, 2 times 2 is 4. 2 times negative root 5 is negative 2 root 5. Then go back, root 5 times 2 is positive 2 root 5. And square root of 5 times negative square root of 5 is negative square root of 25. The whole idea with the conjugate, the reason we use it and it exists is because when you multiply the conjugates together, all your radicals cancel. We have 2 root 5 plus 2 root 5, I'm sorry, negative 2 root 5 plus 2 root 5. It's 0 root 5, which is just 0. So those cancel. The square root of 25, well, again, the square root of 25 is just 5. So we end up with 4 minus 5 is negative 1. That's your denominator. Now, this answer, and like I said, I'm not trying to make it difficult for you, so I'm going to try not to put any like this on a test or a quiz. I think you maybe do have one on the homework today, the worksheet, which, by the way, we do have a win exit ticket today. But your answer is 6 minus 3 root 5 over negative 1. If you put that as your answer, that's fine. I'll accept that. Way to write your answer that's a little shorter. When you divide by negative 1, it changes all the signs to their opposite. So the other way to write this is instead of positive 6, negative 6, and then instead of negative 3, positive 3 root 5. So that honestly would be the best answer. It looks a lot nicer. That's not a fraction. But I'll accept either one. Because like I said, I want to introduce you guys to this. I don't necessarily need to get in the nitty gritty of this. All right, moving on to number 9. Same thing, multiply the top and the bottom, numerator and denominator, by 5 plus root 2. And again, remember, it's the conjugate of the denominator, and the conjugate is the opposite sign. Again, the two most common mistakes on this one where people were multiplying by the conjugate of either the numerator and the denominator. So in this spot right here, they had 6 plus root 2. Option, or they just multiply both the top and the bottom by the conjugate of the numerator. And then the other thing that a lot of people miss is instead of doing the conjugate, they multiply by the same thing. They had 5 minus 2, and that's not going to work out. And if you actually multiply and do all the work, you should find pretty quickly that it doesn't cancel. I have 6 minus root 2, 5 plus root 2, and again, we just 6 times 5. 6 times root 2 is 6 root 2. Root 2, again, you can't combine those. We have a normal number and a radical. Terms, positive 2, negative 5 root 2 is positive 1 root 2. Positive root 2. The square root of 4 is 2. Say 30 minus 28. So 28 plus root 2. That's your numerator. In my opinion, there's a lot going on there. But really, each step isn't too bad. You just got to make sure you're being careful. There's a lot of steps. And this is multiplying. Maybe that's it. If you are okay with multiplying, that's, in my opinion, the hardest part about these problems. And the other one, then, the denominators, we have 5 minus root 2 and 5 plus root 2. Again, when you distribute, 5 and 5 is 25. 5 and root 2 is positive 5 root 2. Negative root 2 and 5 is negative 5 root 2. Then we have minus root 4. So these numbers cancel in the middle. We end up with 25 minus the square root of 4 is 2. 25 minus 2 is 23. So that's your denominator. So your final answer, 28 plus square root of 2 over 23. That's a lot more what your answers will look like compared to the last one. Over -1. A lot of them. And in my opinion, okay with it, or you're at least a little bit with it from the imaginary numbers. When we did, we did the exact same lesson imaginary numbers. Now notice in this one, just real quick, how both the numerator and denominator had a square root of 2. That actually works out really nicely, where you get things that can combine right here, and you get the square root of 4. I'm probably going to, very much the majority of problems like this, I'm going to stick to that. But I do want to make sure, and I haven't decided if I'm going to put one like this on a test or a quiz. Look much different. It's really not. It's just not going to combine as nicely. Which the good news is, if they don't combine very nicely, it's a lot easier. There's not as much steps you can do. The bad news is your answer kind of looks ugly. So this is what I mean by that. If you multiply the numerator and denominator by 3 minus 3, your numerator is 4 plus square root of 7 minus root 3. 4 times 3 is 12. 4 times -3 is -4 root 3. 7 times 3 is plus 3 root 7, and square root 7 times negative square root 3 is negative square root 21. None of that combines. That's like I said, where it's almost easier because there's not as much work that we have to do with it. Once we get to that step, you're done. But it's almost harder, and the fact that that is a very ugly answer. That's the answer. No one's dating that answer. And the denominator still seems really nicely because we had the conjugate, so that one does work out well, or should. 3 plus square root of 3, 3 minus square root of 3. 3 times 3 is 9. 3 negative root 3 multiplies. 3 times positive root 3 is positive root 3. And positive root 3, negative root 3 is negative root 9. So those cancel nicely. We end up with 9 minus 3, square root of 9, which is 6. So all the math is over 6. Okay, I'm still on the fence. I don't know if it's like that on the test or not. Half of me wants to because there's not as much reducing, so it's a little bit quicker. We'll see. If anything, if I do one like that on the test, it'll be like one question. It's going to be a lot more likely, or there's going to be a lot more of the ones like number 9. Okay, you have about 15 minutes left. Go ahead, you can skip 12 and 13. Get out your computer and do the exit ticket, 8.5. I know we've been having a lot of these, but I can capture. I made this late last night, so that's very possible.